Hello everyone! In this video I am going to show you how to make a DIY battery from aluminium foil which can supply electricity in case of emergency. Before starting to make a battery, I need to make a tool which I will use for making the battery, that is a hydraulic press. I prepared two identical 8mm fixed steel sheets. Next I drilled a white hole through them, which I next enlarged to 9mm later on. I took another steel sheet, which I am going to use as a base, and I drilled 4 holes through it, in such a way that they match the other holes I drilled in the other 2 sheets. Having added a few threaded rods and nuts, I have assembled a hydraulic press. This device will produce pressure with the help of such a 5-ton jack. And don't hasten to criticize this device in comments. I know it has lots of defects. Since I had a very limited choice of materials, I had to use what I got. First I ran a test and tried to squeeze 3 toothpicks with this hydraulic press. I was quite happy with the results. Now let us start making the battery itself. We'll start off by making its principal part, that is a carbon cathode. A metal mesh will serve as a current collector. I ordered 2 stainless metal meshes, one with smaller gaps, the other with larger gaps. I cut out 2 current collectors of both metal meshes, roughly the size of a credit card, and I also cut out 2 electrodes. In my experiment, I also want to cover 1 current collector in layer of graphite, thus expanding the surface area. It is a rather questionable move. At this stage, I haven't taken this moment into account yet. I am using a spray graphite. It is used for creating current conducting surfaces. By the way, when it dries, it will leave an extraordinary pattern. I need 2 current collectors for 1 battery I am going to use for making cathodes. In total, I have made 4 current collectors from the mesh with wider gaps and the mesh with narrow gaps. Half of them is covered in a graphite layer. Now is the time to use my hydraulic press. First I need to spray the current collector with activated carbon, which will be absorbing oxygen. I used 2-component epoxy adhesive as glue. It hardens in about 1/2 hours, which gives me enough time to spray activated carbon on the current collectors. After mixing the adhesive components, I applied a thin layer of it to the steel mesh. After applying the adhesive, I just sprinkled the semi-finished cathodes and also 1 plate of the hydraulic press with activated carbon. It is really important to evenly spread the activated carbon in order to make sure that the pressure is spread evenly across the entire surface. Now I am securing the upper plate with nuts and start pressing the carbon cathodes as hard as I can. Then I'll tighten them with the lower nuts. When the applied pressure is high enough, the carbon will stick to the steel mesh much better. This in turn will decrease resistance and increase overall efficiency of the battery. Basically, cathodes can be left like this for 12 hours, until the epoxy adhesive hardens completely. However, if you cannot wait so long, then you can speed up the process by heating it up. I am heating up the place with a burner to about 100 degrees Celsius. Then I leave it out like this for 40 minutes. In 40 minutes it hardened, and then I could loosen the nuts and check what I've got. Generally speaking, it looks quite good. Now I have 2 freshly made cathodes. After that I need to make 6 more for my experiment. In total, I got 8 different cathodes, 4 from the mesh with wide gaps and 4 more from the mesh with narrow gaps. As you can see, the carbon sticks to the current collector very well. When I measure the resistance, I can see it is quite low. Now we can begin assembling the battery itself. First of all, we need to make a battery case. I'm using plastic food wrap for that. I have cut out such packets of them and sealed them with a plastic wrap sealer. In the end, I got a pretty good battery case. Now is the time to make the most important part, that is an anode. I'm going to make it from ordinary aluminium foil. I'm tearing off a roughly 30 by 30 cm piece and fold it in half a few times to make it into the size of a credit card. Also, I need to cut out a small extension, which will be our negative electrode. I'm wrapping a piece of foil in a napkin. By the way, the size of such napkins almost perfectly match the size of my battery. Besides, they are quite thick. Now I'm sandwiching the foil wrapped in napkins between two carbon cathodes. To top it off, I'm putting it into the plastic pocket. After that, I'm sealing it with a Chinese plastic wrap sealer. That is, I have made a classic aluminum air battery. I have also used the 6 other cathodes, in total having made 4 different types of batteries. All these batteries can't work as long as there is no electrolyte in them, which means that they are supposed to last eternally in a dark and dry place. So now we just need to test out these DIY current sources. We need to fill them with electrolyte, that is a solution conducting electricity. For the first experiment, I am using a weak alkaline electrolyte consisting of 5 grams of salt and 5 grams of baking soda dissolved in 100 milliliters of water. First, I am filling this battery with a white mesh and graphite coating with 20 milliliters of the salty electrolyte. A couple of minutes later, it soaked the solution well, and now we can measure the voltage. Just as I expected, the voltage in the salty electrolyte is 0.7 volt. This chemical reaction is quite simple. The anode undergoes a half reaction, where aluminum is oxidized by hydroxides, whereas the carbon cathode undergoes a half reaction, in which water reacts with oxygen and forms these hydroxide ions. In general, the reaction looks like oxidation of aluminum by oxygen in water. It is a pretty impressive result among chemical sources of electricity. This source is even more efficient than lithium-ion battery. Now the reaction is not running smoothly, because there is an oxide layer on the aluminum, which is why the voltage is pretty low. To speed up the reaction, I am adding 10 ml of 10% sodium hydroxide solution. Now we can see how the multimeter immediately shows a rapid increase of voltage. Now the sodium hydroxide has removed the protective layer from the foil, and the voltage has increased to 1.6 volts, which is quite a good result, although amperage isn't very high, just 0.75 amperes. This voltage is enough to supply a small electric motor at low revolutions. Basically, the output of this battery is comparable with the output of a regular AA battery, which produces a similar voltage. I have tested my other batteries. As I anticipated, the best performing battery turned out to be the one with a current collector from a mesh with narrow gaps and without graphite layer. If to connect two of such DIY batteries in series, the voltage will double and the about 3 volts, which is enough to light up a simple light-emitting diode. A red one requires less energy and is easier to light up, whereas a white one needs more volts. That is why here it glows quite faintly. The only problem such a battery has is that aluminum foil which it contains starts dissolving when sodium hydroxide is added. This is why such current source can only run a few hours. However, if the battery and electrolyte are stored separately, they can last 10 or years and be used in emergency. Such batteries are a few times lighter than lithium-ion batteries. That is why are handy when there is an emergency. You can even put a bag with electrolyte inside such a battery bag, pops and starts the reaction. Here is a business idea for you. If such batteries are connected in series, you can even supply small electronic devices. For instance, such a radio. Would you like to listen to the Estonian radio?
Muusikuna sa ütled, et vist praktiliselt ma olen kõik need festivalid olnud nagu kaasas, et kui nüüd üks aasta vahele jäi, siis ma pean natukene rohkem.
This radio is pretty old. I borrowed it from my parents, because I haven't listened to the radio for a very long time. Next, I decided to connect all my other batteries in series, and I got about 5 volts. In order to enjoy music to the full, I can connect my old CD player with my favorite music, for instance with Linkin Park songs, to my DIY battery. However, such batteries don't last very long, and after 5 hours they're completely gone. I think that this experiment is pretty interesting and is suitable for learning electrochemistry and basic principles chemical current sources. If you like this video, don't forget to give it a thumbs up and subscribe to my channel to learn more new and interesting